This is a second example for the one sample Wilcoxon signed rank test. 11 job applicants are randomly chosen from a large group and asked to attend an interview during which each applicant takes an aptitude test to identify which would be best suited to the job available. The mean score on the test nationally is 64. The scores of the most recent applicants were given below. Test the hypothesis using a 5% significance level that this group of applicants have a lower aptitude than found nationally. So with all hypothesis tests, we need to make sure that we identify the 6 key points in our hypothesis test. The first being the hypotheses, stating if it's one or two-tailed, finding the significance level, calculating the test statistic, identifying the critical region, and comparing those two and concluding in context. So let's start by looking at the hypotheses. With all hypotheses, we should have a H0, a null hypothesis, and a H1, an alternative hypothesis. I'm going to be using this letter here. This is the Greek letter eta, and it represents the population average. This question is actually talking about the mean score, so we could use the Greek letter mu for the population mean, but as most of these questions talk about median or average, I'm going to stick with using eta for this question. This question, it tells me that the national average is 64, so my H0, that nothing has changed, everything is as it was before, is that eta is 64. The hypothesis test they're asking me to do is to see if these applicants have a lower aptitude than normal, so less than 64, so I'm going to use that for my alternative hypothesis. Then we need to look if it's one or two-tailed and state the significance level. So whilst writing both of these down don't actually get you any marks for the hypothesis test, it will help you later on in the question when we're identifying the critical region. So I need to look at my H1, and for this one it is eta is less than 64. So because I'm only looking at the lower tail or the lower end of this data, it is a one-tailed test. It states in the question that this is a 5% significance level, and if it doesn't tell you in the question, we must always assume it is 5%. So question 4 is calculating the test statistic. When we're calculating our test statistic, we need to follow the 4 steps. The first one is to calculate the signed difference for each piece of data from the population average. If you're using this video as a revision guide, you might want to pause the video now and see if you can remember how to find the signed differences. So for each value on my data, I'm going to compare that with the average of 64. So 56 is 8 below, 57 is 7 below, 63 is 1 below, 64 is the same as the average, so I'm going to identify that as a difference of 0. 62 is 2 below, 65 is 1 above, so that's going to get a plus 1. 56 is 8 below, 65 again is plus 1, 1 above. 69 is 5 above, so plus 5. 4 below and 3 below. So those are my signed differences. So the second step, step B, is to rank those differences from closest to 0. Now because we are looking to see if values are above or below my national average, the value that I have of 64, if I can highlight that with my mouse here, which gave me a difference of 0, is a piece of data that I cannot use. So I have to discount that. I can't give that a rank. Because if I'm comparing if things are more or less, then an actual value of 0 is not positive or negative, so I cannot include that in my data set. My next values that I have, I've actually got 3 values that have a rank of 1. So I've got this value here, 63 is 1 below, and then I've got 65 twice, which is 1 above. So I've actually got 3 values that have a rank of 1. So they're going to take up positions, a difference of 1. So they're going to take up positions or ranks 1, 2 and 3. But I can't say any of them are better or worse than the other, or worth more than anything else. So they have to share a rank. So if I'm using up ranks 1, 2 and 3, This means that they are all going to have rank 2. Is that what comes in the middle of 1, 2 and 3? Then the next difference I have is this one here with a difference of 2. So because I've used up ranks 1, 2 and 3, that one will have rank 4. Then 3 below will have rank 5, 4 below will have rank 6, 5 above will have rank 7, 7 below will have rank 8, and then I have this one here which is 8 below, and the same again here which is 8 below. They're going to take up positions 9 and 10. So to give them halfway for that, I will give them both rank 9.5. So step C is to calculate the total for the positive and negative ranks. So the first thing I'm going to do is I'm just going to highlight all my positive ranks so I can clearly see which ones are positive and negative. So I've got this one here, 69 was 5 above, that was rank 7. 65 was 1 above, which had a rank of 2. And there was another 65, 1 above, which also had rank 2. So my value for T plus, the total of the positive ranks, is 2 plus 2 plus 7, which is 11. Then I'm going to add up my negative ranks, so I'm going to add up 9.5, 8, 2, 4, 9.5, 6 and 5, and that gives me a total of 44. So the final step is identifying which of those is the test statistic, and the test statistic is the smallest of the rank totals. So out of 11 and 44, my test statistic is 11. Then I want to find my critical region. So to find the critical region, I need to know my value of n. We were told in the question that 11 job applicants and we used 11 pieces of data. However, we had to discount the fourth piece of data because it was equivalent to the mean, and I therefore couldn't compare if it was above or below. So I actually have an n of 10 for this question because the fourth piece of data we could not use. I then need to look on my critical values from table 10. It's called the critical values of the Wilcoxon signed rank statistic, so it has its own tables. I need to look along the one-tailed 5% column, and we've established that n for this question is 10, so my critical value is 11. Therefore my critical region, because this is the lower tail, is anything less than or equal to 11. So to compare and conclude, I cannot draw a statistical diagram for this because it is not a distribution, it is not a normal distribution or a chi-square distribution, so I'm just going to draw myself a scale from 0 to infinity, and I'm going to mark on there the critical value of 11. Anything less than or equal to 11 is the critical region, and that is where I reject. So my test statistic was actually 11 itself, which goes here, and as you can see it overlaps on that critical value, which means that we reject H0. So if I just remind myself of what was actually being asked for in this question so I can conclude in context, it asked me to test the hypothesis using a 5% significance level that the group of applicants have a lower aptitude than that found nationally. We are rejecting H0. We are saying that H0 is wrong, and H0 was that it was still equal to 64. So we are actually agreeing with that hypothesis that there is significant evidence to suggest that this group of applicants have a lower aptitude than found nationally.